Hi, this is Miss G. So we're going to talk about average atomic mass. So let's consider, let's say we're talking about 15-year-olds. Let's just say there's um, like 15 of you that are 15. Maybe there's 10 that are 16 and maybe 2 that are 17. So when we're considering average atomic mass, what we're going to do is consider the percentages. So what you end up doing is you end up adding them together. So this is 27. So we want to figure out the percentage of 15-year-olds in this class. So we're going to do the 15 divided by the 27, and we end up with 55.6% of 15-year-olds in this class. I'm just making these numbers up. We have 37% are 16-year-olds, and then we only have 7.4% that are 17. So these percentages, what I just found out, are what we call relative abundance. So we're going to do something similar with the elements, isotopes. So when you talk about average atomic mass, you're talking about the mass of protons and neutrons, but then you're talking about the relative abundance, which is the percentage of how many times it happens. So, and this gives us, we're going to use that to figure out our average mass. So the average atomic mass, when we look at our periodic table, on our periodic table, it's actually the upper left. So for carbon, if we look at carbon, on our periodic table, it's 12.0111. It's the upper left. So it's the average of all the isotopes. The isotopes have the different weight. So for instance, the helium is 4.00260 on the upper left. That's our average atomic mass. So the formula we're going to use is this for average atomic mass is mass of the isotope times the decimal percent of isotope 1, mass of isotope 2 times the decimal percent of isotope 2, and any remaining isotopes. So it says naturally occurring bromine consists of 50.69% bromine 79 and 49.31% bromine 81. What is the average atomic mass of bromine in AMU? So we are going to take these percentages and divide them by 100. So that's going to give me 0.5069. And then this percentage, we're going to take it and divide by 100, giving me 0.4931. All right, so what we're going to do is take the decimal, the 0.5069, and we multiply it. This goes with the 79 times, that's a times 79. And then we're going to add 0.4931 times the 81. So we're going to put that in our calculators. We're going to do parentheses. Giving us 79 0.9862. So we're going to round this to 2 decimal places. If I round that, that rounds up. So it's 79.9 99 AMU. That's my unit. All right, so chromium has 4 isotopes. Chromium 50 is present 4.35% in nature, so this can go with this. Chromium 52 is present 83.79% in nature. Chromium 53 is present 9.5% in nature, and chromium 54 is present 2.37% in nature. What is the average atomic mass of chromium in AMU? So we want to take the 4.35, divide by 100, divide this by 100, divide this by 100, and also the 9.50. But we have to make sure we line them up correctly. So we're going to do 4.35 divided by 100, which is 0.0435 times 50 plus, so 83.79 divided by 100 is 0.8379. Times 52 plus 0.0950. That's just 9.5 divided by 100 times 53, and then the last one, which is 0.0237. That's just 2.37 divided by 100, and then times that by 54. And put that in our calculators. And we get the answer here. I'm going to put it at the top. Here is 52. I'm going to 0.0606. I'm going to round it to 2 decimal places, so it's 52.06 AMU. So that's my answer right here. Okay, so that's all we have. And you can watch the video on your notes or on the Google Doc.